In today's elimination that we're going to do, we're not going to have what happened yesterday. When we look at the equations, we're either going to automatically have opposite x terms or opposite y terms, and we can go right to work adding them together. What's going to happen today is we may need to rename.
I need the following to the junior high office, please. Maggie Overlander, Heather Fisher, Braylon Franz, Benson Murray, and Sam Byerly. Thank you.
So, and notice it says, sometimes you will need to rename one of the equations before adding them. When you were SQ3R, you might have discovered that sometimes you actually have to rename both of them. We'll deal with those tomorrow, okay? So today, you're going to need to rename one of the equations before you add them together. So what you're going to do to rename them is multiply one of them by a value that will create those opposites that we needed, that were not there like they were in the ones we dealt with yesterday. So we need to create the opposites today. And today I've picked out problems where you should only have to rename one of the equations. So you get to decide which one to rename, but make it so you only have to rename one of them, okay? Don't get ahead of yourself. Okay, let's look at our first system that we're going to practice here. 2x plus y equals negative 5. 2x minus 5y equals 13. Right now, do we have opposite x terms? No. Do we have opposite y terms? No. But let's create opposite x terms. I've kind of picked the one we're going to do it in. We could also multiply the first one, but let's create it in the second one, okay? Because I want us to practice with those subtraction ones that give everybody a lot of trouble, okay? So we're going to multiply this equation, 2x minus 5y equals 13, by something that will create opposite x terms. What would we have to multiply by? Negative 1. So we're going to take that second equation and we're going to multiply both sides of it by negative 1. And what I'm putting in parentheses are the original parts of the equation. And I'm showing that we're going to multiply both sides by negative 1. We can do anything we want to equations, anything, as long as we do it with both sides. Let's change that subtraction to add the opposite so we're more successful. And let's do our distributive property on the left side. What do we end up with on the left side?
Negative 2x plus y.
Negative 2x plus a positive 5y, because a negative times a negative is a positive. And what's our right side become? Negative 13. We've only renamed this equation, and we did it, as I call it, legally. So I want you, in your notes, I want you to note that. That's what we just did. Second equation, that's the one we picked. I picked for you, I shouldn't say we. Renamed. What is that about? Well, just like when we were doing substitution, if we renamed an equation, we got x or y by itself, we ditched its old name and we started to work with its new name, didn't we? So we're going to do the same thing here. We're going to say, okay, now I'm ready now to add them together, so I'm going to write down my two equations in an addition problem. And now we're in the same spot we were yesterday. We have the opposites. When we add them together, the x terms are going to eliminate, and the y terms, we're going to be solving for y first. I get them to add up to negative, or not negative 6y, positive 6y equal to negative 18. Do you agree? So then we will divide both sides by 6. And we will get y equals negative 3. There's our y value. Today we can just keep working down. We're not going to do a check problem, so we have some space left here, don't we? Okay, now, we actually have 3 equations. In reality, we have three different equations. We can take that y value and substitute it back into. We have the first equation, and then we have the second equation, and its new name. So you get to pick any of those and solve for x. Should we use the first one, 2x plus y equals negative 5? Okay. Looks like the least painful one, maybe. So we're going to substitute into, we are now going to find x. So 2x plus negative 3 equals negative 5. Go ahead and solve for x. Negative 1. So, last but not least, our solution is what? Where were these two lines cross on the graph?
Negative 1,
Negative 1, negative 3. Now, here's how they handled this one in the book, a problem like this. They did subtraction. You recognize that? They did subtraction. They put the whole equation in parentheses, put a subtraction sign out front, and then you had to subtract each of them. Now, I tend to teach it this way instead. Instead of doing a subtraction problem when the x terms match or the y terms match, when they're the same as each other, instead of doing a subtraction problem, typically I find students are far more successful with treating those kind by doing what we just did, multiply by negative 1. Rename one of them by multiplying by negative 1. So what I'm saying here is, right here at the beginning, we had matching x terms. In your textbook, they will treat this as a subtraction problem. How many of you felt like you were successful in doing the subtraction check it out problems in your book? They were trickier, weren't they? Do you think this will work better? So I suggest use this multiplying by negative 1 rather than subtraction. I think it's going to go better for you, okay? So any concerns before we move on? These are the ones where the x terms or the y terms are matching. Okay, well then let's go to the back and see what we have back here. Okay, do we have opposite x terms or opposite y terms? No, so then we can't go right to adding them together. Do we have matching x terms or matching y terms? No, so we can't go with multiplying by negative 1. So what we need to do is create opposites. So we have all kinds of options here. We can create opposite x terms. We can create opposite y terms. We can make as much work as we want for ourselves, but today I said let's not do anything more than rename one equation. So which equation do you want to rename and how? Jacob.
I want to multiply the bottom one by negative 2.
Okay, you want to multiply the bottom one by negative 2, and that might even get rid of some of those negatives, huh? Okay, so we're going to rename by multiplying, put this in your notes so you know what we did, by negative 2. Can anybody, not Jacob, but somebody else, can somebody else tell us why would we multiply by negative 2? What's the goal there? Courtney? Yeah, so we can end up with opposite y value. Then we'll have opposite y's. If we have a positive 2y, we would get a negative 2y by multiplying by negative 2. So we're going to take that negative 2 and we're going to multiply both sides of that equation by it and get that one renamed. Okay, is its new name 6x plus negative 2y equals 10? Okay, now what do we do with that?
We do the same thing that we would do with Visuals.
So that just replaced, it's its new name, so now we say, okay, now they're ready to add together. So I'm going to take my first equation that did not get renamed, the new name for the second one, and set up our addition problem. Okay, you go ahead and solve this, and let's see if we all end up, all the way through, get your ordered pair answer. Let's see if we all end up with the same answer. Because now we're to the point of doing exactly what we did for today. Are we in agreement? Our x and y value, ready to set up our ordered pair solution? Okay, our solution is 3, 4. Okay, in your homework for tomorrow, you are going to get times where you will not get integer answers. That does not mean something went wrong. Okay? When we're learning, we have been practicing with ones that get integer answers. But in your homework today, I have to have you practice when we don't get integer answers sometimes. Okay? So I'll tell you which ones, and you can put it up your big sleep, which ones that'll happen in. So if you want to get your big sleep up to get your heading going,